Hi friends. In the previous video, I was already explained the pin description of ADC controller, right? So what are the various pins and what are the functioning of each pin? We discussed detailedly. Now in this particular video, I will give you a brief idea about how 8086 is interfacing with the ADC. Okay, so with 8255 as well as without 8255, how they are interfacing 8086 with ADC. Let us see. Okay, see the heading. I will make it full screen. I will highlight it. Okay. See the topic interfacing. Here interfacing 8086 with ADC. Okay, interfacing 8086 with ADC. Let us see here. Assume this is your microprocessor system. Okay, generally we are considering as 8086. Okay, then assume this is your ADC. So having 0803 family or 04 or 05. Okay, so like that they are connecting. So in ADC we have read bar, write bar, clock in. Okay, similarly clock out also. Right. So clock in is connected to clock out. Here clock out is connected to clock in. Here also we have in plus and in minus. Okay, these two are analog input pins, and it is having 8 data lines. After converting, we get 8 data lines, DB0 to DB7, and these 8 lines are connected to microprocessor system. And INTR bar is connected to NOT gate to INT signal. Okay, and now here this is read bar, write bar of the microprocessor system. Then we have set of address lines. Address lines are connected to address decoder for activating CS bar. Okay, this is the standard representation not only for 8086, for any microprocessor system. Okay, how ADC is interfacing to any microprocessor system. Here let us see what is your observation first. Till now we observed only connection part, but the first part, in order to make ADC into operation, we should activate CS bar. For that, in which way we are activating CS bar, here we are taking set of address lines from the microprocessor. Okay, those address lines are connected to address decoder. Then address decoder will generate output as 0. That 0 will be given to CS bar. Then CS bar is activating. So one address decoder may generate 8 outputs. Here one output is enough. So Y0 to Y7 are appeared. For example, Y0 is connected to CS bar. Y0 is 0 generally. Okay, 0 is given to CS bar, then it will activate. Like that, CS bar is activating with the help of address lines through address decoder. Now next is write bar signal. So write bar signal is connected to processor write bar signal, microprocessor write bar signal. For example, write bar is 0, then 0 is given to write bar, then it will activate. Whenever write bar is activating, what happens? Now ADC will takes the analog data from any of the external analog input device. So in plus and in minus, these two are analog pins, and in plus is connected to analog input, and in minus, if you want, you can connect it to ground. Okay, like that, these two pins receiving the analog input. Okay, whenever write bar signal is activating. Okay, now let us see read bar. When we are activating read bar, so read bar signal is activating only when the conversion is completing. Okay, when the conversion is completing, then only we are activating read bar signal. So generally, I already mentioned INTR bar signal must be high during the time of analog to digital conversion, and it should be low when conversion is completed, right? So now let us see here, whenever INTR bar is 1, okay, during the time of conversion. So then because of not, what is output? 0. 0 give it to INT. Then microprocessor understood that conversion is not completed. So whenever conversion is completed, what happens? INTR bar becomes 0. 0 because of not, if it is 0, because of not, what is output? 1. 1 is given to INTA, then it will activate. Then microprocessor understood that conversion is completed. Then it will activate the signal, read bar signal. Okay, then these 8 data lines are now transmitted to data bus buffer of the through data bus buffer to microprocessor. Okay, like that we can analyze overview of how ADC is interfacing with microprocessor, generalized microprocessor. Okay, let us see same thing like a timing diagram. So initially CS bar must be activating. Here, no, this is the 0. Actually, this is 1. Low means 0, high means 1. So when CS bar and write bar signals are activating, if you give 0 value, low values here. Now in this time CS bar is low, same time write bar is also low. Then what happens during this time? We are activating ADC, and similarly we are activating write bar. Then what happens? ADC will receive the analog data. Okay, if you activate write bar, ADC will receiving the analog data. After receiving analog data, what happens? It starts conversions here, start of conversion taking place. Okay, so now this is the accessing time. Okay, now conversion starts from this point. conversion, for example, end here. Okay, then during the conversion time, what happens? INTR bars here, INTR bar, whenever during the time of starting the conversion, INTR bar must be high, nothing but busy, high. Okay, so later what happens when conversion is completed? For example, here during that time, what happens? INTR bar is low, then it indicates that conversion process is completed. So whenever conversion is completed, what happens? Now read bar signal we are activating here. Here we are activating the signal, read bar signal. The read bar signal is now low whenever data is available. Nothing but conversion is completed. Like that we can analyze. Okay, how the pins are enable or disable as per the requirement. Okay, now these two are the generalized microprocessor. Now let us see for 8086 microprocessor how they are interfacing. See this diagram. Now see here interfacing of ADC 0803 or 04 or 05 family to which one? 8086 microprocessor without 8255. Here without 8255, let us see how now this side is 8086 here. Data lines, IO read bar, IO write bar and address lines all are from microprocessor. Okay, now this is your ADC. Assume this is your decoder, address decoder. Let us see here how we are connecting. So here also in plus is connected to which one? Analog input, and in minus is connected to ground. Here also CLR, CLK, and nothing but clock out and clock in, clock out and clock in. These two are connected to externally with the elements R and C with this arrangement. And here we are choosing that R is equal to 10K and C equal to 150 picofarad. Substitute this R and C in that clock frequency formula in the last video I mentioned, equal to 1 by 1.1 into RC. Okay, that much clock frequency this IC will generate. Okay, reference by 2 is connected to reference voltage. Okay, reference voltage, for example, 10 volts. If you connect reference by 2, it becomes 5 volts. Analog ground, because this side is analog, that's why I'm considering as analog ground connected to ground. Okay, this side is digital. Let us see here. The important point is how we are connecting. So read bar and write bar, these two are connected to processor IO read bar and IO write bar. Because here I am taking which mapping? IO mapped IO. So for selecting IO mapped IO, number of address lines should be 8. So here A0 to A7, total 8 address lines I am taking. Then which type of IO mapping here? It is IO mapped IO, not memory mapped IO, IO mapped IO because of 8 address lines. So that's why I am calling as IO read bar and IO write bar. Okay, this is decoder. Decoder having 3 set of input signals like A, B, C and 3 control signals like G1 bar, G2 bar and G. So when we get output Y0 to Y7, here in this case 2 are enough, but this decoder may generate maximum of 8 outputs. So when all 8 outputs are zeros, only by activating G1 bar, G2 bar and G. So when these 3 are activating, G1 bar is activating by giving 0. So when it is 0, A3 is 0, 0 given to G1 bar, then it will activate. So A3 must be 0 for activating G1 bar. For activating G2 bar, A4, A5, A6 must be zeros. Then because of our output is 0, 0 give it to G2 bar, then it will activate. So A3, A4, A5, A6 must be zeros for activating G1 bar and G2 bar. And A7 must be 1, then only we can activate G. Okay, like that A7 must be 1 and A3 to A6 must be zeros. A0, A1, A2, we can give you randomly the zeros or ones because these 3 address lines are connected to decoder input lines. Input lines we can give either zeros or ones. Okay. So the IC number for decoder is 74LS138. 74LS138 is the address of this decoder. Now, okay, now let us see data lines of ADC having 8 data lines. Then these 8 data lines are connected to lower byte of the processor data bus. Okay, right. Read bar is connected IO read bar, write bar is connected IO write bar, and INTR bar is connected to lower byte of the processor. Okay, lower byte of the processor. So now here important role is INTR bar. Let us see first, now this ADC is receiving analog data. Then what happens with this particular clock frequency, analog data is converted it into digital data. So during the time of conversion, what happens here, see here, a decoder generates 2 outputs in this example. Y0 is 0, Y2 is 0. 0 is given to CS bar, then it will activate first. So now Y0 is also 0. 0 give it to not, what is the output now? 1. 1 is given to INTR bar, then it is inactive. Nothing but whenever if you give analog input, then after activating CS bar, if you give analog input, then with this clock frequency, the analog data is converted into digital data. During that conversion time, what happens? INTR bar is 1 because Y0 is connected through NOT gate to INTR bar. Whenever Y0 is 0, 0 is connected to NOT gate, output of NOT gate is 1. 1 is given to INTR bar. Okay, then it indicates that analog data is converted it into digital data. So whenever conversion is completed, then what happens? This INTR becomes now low. Low means 0. 0. Okay, then this 0 information is given to lower byte of the processor. Then the processor understood that conversion is completed. Okay, then it will read the data, digital data that is available in the DB0 to DB7 lines through lower data bus of the processor. Through this data lines, digital data is reading. Like that, we can interface 8086 with ADC without 8255. Let us see with 8255 how we can interface. See the next line. Now, so this is the heading. See what is our heading? So interfacing of ADC 0803 family to 8086 using 8255. Let us see how we are interfacing. See, the right side portion of ADC 0804 is same. Analog input, in minus, clock out, clock in connected to externally RNC elements, reference by to connected to V reference, analog ground is connected to ground, same. Okay, so now see the pins here, DB0 to DB7, write bar, okay, read bar, CS bar, INTR bar are present. In which way they are connecting? If it is a 8255 is present, 8255 having 8 port A pins, 8 port B pins and 8 port C pins. See here, now this digital data is now received by port A pins. DB0 to DB7 are connected to port A pins PA0 to PA7. Write bar is connected to PB0. So whenever PB0 is 0, write bar is activating. Then analog data is now received by the ADC device. CS bar and read bar both are connected to ground. Or if you want, you can connect CS bar and read bar to PB1, PB2. Okay, assume PB1, PB2 both are 0 zeros, then ADC is ready, like that. INTR bar is connected to PC0. So during the time of conversion, INTR bar is 1, then that information is conveyed to PC0. Whenever conversion is completed, it becomes 0. Then PC0 understood that conversion is completed. That information is given to processor, then transmitting the data lines DB0 to DB7 to port A, then port A transmitting same data with the help of 8 data lines to processor data bus. See, this portion already we learned in the previous video. In the previous videos also we observed how 8086 is interfacing with 8255. Same case here also. Let us see 8255 having 8 data lines DA0 to D7. These data lines are connected to processor data bus. Okay, and 8255 having 2 lines, read bar, write bar, and 2 address lines A0 and A1. It is a modification A0 and A1. So A0 is connected to A1 of processor address bus, and A1 is connected to A2 of processor address bus, and reset is connected to reset. Here also we are activating CS bar with the help of address decoder. Here we are taking set of address lines through NOT gate, then NAND gate. So for example, A3 to A7 all are zeros. Because of NOT, all becomes ones, and because of NAND, output is 0. 0 give it to CS bar, then it will activate. Okay, here also M by, now this is IO mapped IO, because how many address lines are present up to A7, nothing but A0 to A7. So it is a direct addressing mode, that IO mapped IO. So in the IO mapped IO, we should activate which one? IO bar. Let us see for that, M by IO bar must be low, then we are selecting IO bar, read bar also low, A0 is low, okay, these 3 are low, then output should be IO read bar. That IO read bar is connected to read bar of your 8255. Similarly, write bar is connected to 0 and given to one input of OR gate. A0 is already 0. M by O bar is also low. Then we get output is 0. Name, call it as a IO write bar. IO write bar is connected to write bar of 8255. Like that, they are interfacing 8086 with 8255. Then 8255 is interfacing to ADC. Here also, see here, first we should activate CS bar and write bar. Then what happens whenever CS bar and write bar are activating? If you give analog input, then that analog input is accessed by the ADC. Okay, so then it will start converting analog data into digital data. During that time, INTR bar must be high. So whenever conversion is completed, then INTR bar must be low, and we are activating a read bar signal at that time. Okay, and whenever INTR bar is low, then 825 understood that conversion is completed, and that information is transmitted to processor via data lines. Then processor will receiving the 8 bits of data from ADC through port A, and data lines of 8255. Like that, we can interface 8086 to ADC using 8255 IC. Okay. Like that, we can analyze the interfacing of ADC with 8086 through 8255. I hope you understand the interfacing of ADC with 8086 with 8255 as well as without 8255. Okay, if you really understand, please kindly share my video to your friends and subscribe my channel. Thank you.